Hi there, in this video I'm going to be showing you how to prove the chord theorem. Let's say we have two chords within a circle like so, where the segments are A, B, C and D. Well, it turns out that A times B is going to be equal to C times D. And in this video I'm going to show you how to prove this. Firstly, let's show that the angle up here in this diagram is half the angle over here at the center of this circle. So this line over here is the radius of this circle. This is also the radius, and this is also the radius. So this object over here is made up of two isosceles triangles. Now let's call this angle up here x. If that angle is x, then this angle over here also has to be x. Let's call this angle here y, and if the angle over here is y, then this angle over here must also be equal to y. Now we're going to draw an extra line over here, okay, and this entire line is actually going to be the diameter of this circle, okay. Now this angle over here is going to be pi minus 2x because there are 180 degrees inside a triangle, and this angle over here is going to be pi minus 2y, okay? If that's the case, because halfway around the circle is 180 degrees, right, then this means that this angle over here is going to be 2x, and this angle over here is actually going to be equal to 2y. So as you can see, if we combine these two angles over here, we get 2x plus 2y. Okay, but factorized, that is 2 times x plus y. So we've proven that this angle over here, 2x plus 2y, is double the angle up here, which is just x plus y. So we have the first part of our proof. Now the second part of our proof is showing that these two triangles over here have similar angles, okay? So let's call the angle up here x, and let's call the angle up here y. Now they may look different, but it turns out that they are the same. It's because this angle over here is 2x. We can see this because of this previous theorem over here. This angle over here is going to be double that x. But it also turns out that this angle over here is actually 2y as well. Okay? Because it's going to be double y, this angle up here. And once again, that's because of this proof over here. So if 2x is equal to 2y, right, and we divide both of these, of the sides of this equation by 2, we get x is equal to y. Okay, so we've shown that the angle up here is the same as the angle over here. Now let's call these two angles phi, okay? If these two angles over here are phi, then this angle over here is going to be pi minus theta plus phi, okay, because we have theta over here and these two opposite angles are the same. This angle over here is also going to be pi minus theta plus phi. Okay, so as we can see, these two triangles over here have very similar angles, and this forms the second part of our proof. Now let's go back to this diagram here on the left. What I'm going to do is put a line over here like this, and I'm going to put a line over here like this, and we form a triangle to the left and a triangle to the right. Now, if we add some angles to these triangles, we're going to be able to come up with our proof AB is equal to CD. Okay, so I've put some angles in these two triangles over here. It turns out if this angle up here is x, then this angle over here also has to be x because of our proof to the right. If this angle here is y, then this angle down here also has to be y. And these two angles here are opposite angles. That's why if this angle here is z, then this also has to be z. Now all we have to do to prove that a times b is c times d is use the sine rule. Okay, so what we're going to say is that a, okay, over sine x, because x is the angle opposite to a, is equal to, let's see, that is c over sine y. Okay, so that's c over sine y. Now, if this is the case, then a over c is going to be equal to sine x over sine y. Okay, also, the angle opposite d is x, okay? So we're going to say that d over sine x, like this, is equal to, that is going to be b over sine y. Okay, so that's b over sine y. If this is the case, then d over b is going to be equal to sine x over sine y, like so. Now check this out. A over c is equal to sine x over sine y, and d over b is equal to sine x over sine y. This is going to imply, okay, that a over c is equal to d over b. Now let's multiply both sides of this equation by b. So we get ab over c is equal to d. Now let's multiply both sides of this equation by c. If we do this, we show that ab is equal to cd. Okay? And we have our proof. We've proven the chord theorem. If you have any questions related to this video, leave them in the comment section and I'll get back to you as soon as I can. If you'd like more maths proofs, make sure you're subscribed to my YouTube channel and also check out mathematics.proofs on Instagram. Thanks for watching this video and see you next time.